Kia ora, my name's Ruby and welcome to my ecology video. I hope you enjoy. Today we'll be learning about how New Zealand was once a part of the supercontinent called Gondwana, New Zealand's separation from it and how the isolation has affected our flora and fauna. Cast your minds back to 80 million years ago to when New Zealand was once a part of the supercontinent Gondwana. There is to be believed that there has been 7 supercontinent phases that have formed our homelands today. About 280 to 230 million years ago, there was the Pangaea period. This landmass was broken off into 2 separate fragments, Laurasia, which was part of the northern separation, and in present, the continents of North America, Europe, and Asia. The southern fragment was called Gondwana. The remains of Gondwana today make up about 2/3 of today's continental area, including South America, Africa, Antarctica, Australia, India subcontinent, Arabia, and New Zealand. Now that we know more about the continents that make up Laurasia and Gondwana, let's go more in depth on the separation of New Zealand from Gondwana. New Zealand is located on the eastern side of the supercontinent, situated next to Antarctica and Australia. The separation and fragmentation of New Zealand was caused by movement in the Earth's crust. Around 80 million years ago, a fragment of eastern Gondwana broke off and New Zealand separated. This gave way for the Tasman Sea to be created, and New Zealand was on its 55 million year journey to where it is now situated. We are located about 2,000 kilometres from eastern Australia and have maintained our position ever since. We have now essentially become an isolated island, not close to any large land masses. I briefly interrupt you to mention how New Zealand's position on the globe affects New Zealand's climate. The North Island and the more northern fragment remains a more subtropical climate, whereas the South Island has more temperate and variation in conditions. Moving on to how that isolation from larger land masses has affected our flora and fauna, there are 3 major giveaways: Gigantism, Flightless Birds, and white flowers. Allow me to explain. Let's dive into island gigantism. What is island gigantism, you may ask? Well, let me tell you. Island gigantism occurs when the absence of constraints, such as predators, allow endemic species to grow larger than other places. We can see this occurrence in many flora and fauna species in New Zealand. Let's start with fauna. Here are a few outstanding participants: the moa, the haast eagle, and the giant weta. Because of the lack of mammal predatory species, this gave way for our endemic species to adapt and evolve into larger versions. Now the moa. They were large flightless birds that are endemic to New Zealand. They averagely reached a height of 3.6 metres with an outstretched neck and weighed around 230 kgs. The smallest of the species being about the size of a turkey. Because of its larger size, the moa had virtually no predators, bar one. The haast eagle, of course, which is another form of gigantism in itself. Moas being herbivores in nature and being larger in size, this allowed them to reach a greater variety of vegetation. Whoa, a 2.3 metre wingspan? Not possible! Let me introduce to you the haast eagle, a beautiful example of gigantism. It is the largest known eagle to have ever existed, weighing around 15 kgs, its favourite snack being the moa. As we know, the moa weighs around 230 kgs, but that doesn't stop the haast eagle. Whoa, that's a big difference, 15 kgs to 230 kgs. I know, but its main attack being ripping into the moa's internal organs and the moa dying from blood loss, and then the haast eagle feeding on its body. Because there were no other mammal predatory species, it had no one to compete with. The giant weta, also known as wetapanga. Wetapanga is the largest of its species, and when they are fully developed can weigh as much as a mouse or a small bird. That's pretty big, don't you think? That is very big. The female weta can weigh 35 grams more than the common house sparrow. You can find the wetapanga in the Northland, Auckland area and Great Barrier Island. They spend most of their time among the foliage during the day and leave their nests at night to travel through the trees or on the ground. They filled the role of rodents and land mammals before there were any introduced species, so they adapted to have a larger range of food source, much like the moa. Wetapanga like to feed on native plants and prefer larger leaves like the karaka, karamu, mamanangi, mahaui, and kohikohi. Moving on, let's talk about the flightless bird. Flightless bird's main predator was the haast eagle. Now, as the haast eagle spends majority of its predatory time in the air, the kiwi, the kakapo, and the moa no longer needed to utilize that space. So they evolved and adapted to utilize the ground as it became more of a risk to be flying in the air. This meant that their body composition changed as well. They gained more body weight and size, and their wing strength became less. The kiwi is a beautiful example of these adaptations. They have become more camouflaged to blend in with the ground. They are about the size of a chicken and have similar characteristics to a badger. Their claw-like feet that they use to dig burrows. They have whiskers like bristles on their faces and shaggy plumage that looks similar to fur and not feathers. It is believed that the kiwi took on these adaptations in replacement of predatory species, although they mainly feed off worms and other small insects. Kakapo is another great example of a flightless bird. Kakapo are the only flightless parrots in the world, and they are also the heaviest. Another effect that isolation of New Zealand has had is that these birds, in particular the kiwi and the kakapo, have evolved to become nocturnal, meaning they only come out at night and hunt. The kakapo is a herbivore and mostly feeds on native plants and berries. As you can see, those evolutions and adaptations that our native species have taken are having a greater effect on them now, because we now have introduced predatory species, and those adaptations and evolutions that they once took are no longer protecting them. Moving on to white flowers. Ruby, how are white flowers an indication of isolation from larger land masses, may you ask? Well, let me tell you. Because we're not close to any larger land masses, this meant that we have an altered pollination conditions, which have influenced the floral genetics. Insufficient pollination has meant that the florals have been pollinated by a smaller variety of pollinators compared to larger land masses. These main pollinators in New Zealand are the honey, bumble, and native bee, a few select flies, butterflies including monarch, yellow, red admiral, and copper. Also, the white moth and Cleopatra beetle, compared to the mainland, which has a much larger variety of pollinators. Often, isolated islands, such as New Zealand, have less genetic variation in flowers, the result of this being more dull and whiter petals in colour and also smaller petals. Well, that concludes my video. I hope you've enjoyed learning some interesting facts about how New Zealand has been affected by being isolated from larger land masses. Ka kite.